Welcome to Ask and Learn.
Hi everyone, so what we have here is a satellite that's in circular orbit above the Earth such that it always remains over a certain point on the Earth's surface. Therefore, the period of the satellite should be 24 hours, or as to solve for is the height of the satellite above the Earth's surface and the velocity or the orbital speed of the satellite. And the way that we're going to be solving this problem is by using the definition of period of an object rotating in an orbit. So let's go ahead and get started. So the period of a satellite is given by t equal to 2 pi r naught all over vs. Here our r naught is our height, or essentially the radius of our circular orbit. So r naught is going to be equal to h, which is the height above the Earth's surface, plus the radius of the Earth. By plugging in these quantities into here, we'll see that the period, which is supposed to be equal to 24 hours, we'll do that in seconds, is going to be 24 times 3600 is equal to 2 pi r naught all over vs. We can go ahead and isolate vs, and we'll see that this is equal to 2 pi times r naught, which we know to be h plus the radius of the Earth, all over 24 times 3600. So this is our velocity in terms of h. Next, what we can do is we can go ahead and determine the velocity itself. So we know that the velocity of the satellite orbiting around the circular orbit of radius r naught is going to be equal to vs, which is equal to the square root of g times the mass of Earth all over r naught. This is, after we plug in the values that we know, this is going to be equal to 66.73 times 10 to the negative 12 times 6 times 10 to the 24 all over h plus re. Now, as you can see here, this is another equation of vs with respect to h. So basically we have two equations. One equation here, this is equation 1, and we have equation 2, and we can directly simultaneously solve these, and this gives us that the height above the Earth is equal to 36 times 10 to the 6 meters, and the velocity vs is equal to 3.07 kilometers per second, and that is our final answer.